All right, so here we have stopping distance. So suppose a person driving down the road at 88 feet per second sees a deer on the road 200 feet in front of him. His car's brakes, once they have been applied, produce a constant deceleration of 24 feet per second squared. He applies the brakes 1/2 of a second after he sees the deer. Can he stop in time or will he hit the deer? Explain. All right, so we've got a lot of things to work on here. So let's start with kind of writing down what we know. So we know deceleration. Well, that's going to be our A of t. So last time, when we had the diver, A of t was equal to something. Well, this time he's decelerating. So instead of being positive, it's going to be subtracting 24 feet per second squared. Okay. So that's given. So now with that, maybe we can determine all that position and everything like we did last time. So next thing we looked at then was velocity. And so that's going to be v of t is equal to our integral of negative 24 dt. And that's going to give us a negative 24 t plus c. Now, do we know anything initially? Well, we know he was initially driving, I suppose it was a person, at 88 feet per second. So if he's going 88 feet per second initially, so that's going to be at time equals 0, the velocity is equal to that. So we can say, okay, well, 88 equals negative 24 times our velocity plus c. Well, guess what? That's 0. So c is equal to 88. So our v of t then is equal to a negative 24t plus 88, and our velocity is in feet per second. So now we can, at any time, we can determine how fast they're going. Now, what else do we need? Well, now we need position. So position. Well, that's the integral of v of t, so that's going to be the integral of negative 24t plus 88 dt. And so it's going to be negative 24t squared over 2 plus 88t to the 1 over 1 plus c. Okay, so we got that. This could be reduced, I guess, if we wanted to a negative 12t squared plus 88t plus c. Now, when at time 0, where was he? Well, at time 0, if we think about that, he's driving down the road. Time 0, he's at 0 things, because over here, there's a deer at 200 feet. And so at time 0, he is at 0. So 0 is equal to basically the 0 and 0 and c. So that's equal to c, basically, because those both go to 0. And so our p of t, so let's call it again, s of t is equal to negative 12t squared plus 88t plus 0, which we'll just leave off, okay? So we've got that now. So now let's go ahead and think about what we have. When is the velocity going to be equal to 0? Because that's when he's stopped. So, he's going 88 miles per hour this direction, headed toward the deer, or 88 feet per second, sorry. And at some point, he's going to stop. We don't know where. Is it going to be before the deer or after the deer? We're not sure. And so what we have to figure out is, when is the velocity 0? So let's start working on the stopping distance. So we've got our formulas now, so let's think about things. So when is velocity equal to 0? Well, 0 equals, now we have negative 24t plus 88. So if we take 88 to the other side, we'll take 88 divided by 24, and we get 3 2/3 second, it looks like. So 3.667 seconds. Okay. Well, now we can say, well, how far is that going to be? So our position, well, that's going to be S of 3.667. Well, we found that's down here is negative 12 times 3.667 squared plus 88 times 3.667. And that gives us negative 12 times 3.667 squared plus 88 times 3.667. That gives us 161.333 feet. So that's his position stopping. But guess what? We also have to think about how far did they travel in that half a second, because that's how far he traveled once he hit the brakes. But he had to, or they had to go a half a second before that. So we have to think about the half a second of travel. Well, that's going to be 88 feet per second times 0.5. So that's going to be 44 feet. So now the total distance traveled after they see the deer is going to be 161 point that plus 44. And so that's going to give us 205.33 feet. And we'll put another 3 there. So guess what? Bambi just got ran over because they only were 200 feet away. He had 205.33 feet before he actually stopped. So we have a dead deer. Unless the deer was lucky enough to run away. In that case, then we don't have a dead deer. But if it didn't, and he got the deer in the headlight look and just stood there, then we have some hamburger there on the highway. So that would be that one. So again, we had to do kind of what we did on the previous question. We had to do deceleration, velocity, position, whereas the last one was the acceleration, velocity, position. And then this one, we add in that stopping distance. So how far did they take to stop? And we had to think about, well, just the velocity and position plus that extra half a second of reaction time and how far did they travel in that amount of time. And then we found out that Bambi wasn't going to make it this time. All right, so that's all I have. Hopefully that helped.